So this is all about EPRs, this next section. In our final section, by the way. So, right. We have completed the cycle when we finish this. So let's talk about an EPR, an evaporator pressure regulator. What is the purpose? When we control the pressure of our evaporator, what's the refrigerant condition inside my evaporator? What is it? Saturation. Right? Because I'm at saturation, my PT chart applies. Right? It applies because I have liquid and vapor in the same place, at the same time, then my pressure equals temperature. My temperature equals pressure. Right? That means I can control my pressure. I'm also controlling the temperature of my evaporator. 1 to 1, right? Direct correlation. That's why I have a PT chart. So when I have an EPR, an evaporator pressure regulator, I can think of that as I am controlling the temperature of my coil, because that's what we're doing. Right? That is the purpose, is to control the temperature of my coil very precisely. Right? That's why I have an EPR, so I can control the temperature of my coil. Now, if we think about the cost of an EPR, EPRs are not inexpensive, right? These days they're around $1,000, right? When we go to the electronics, they're even more, okay? We also think about our customers. These guys are running on a shoestring, some of them, right? They're trying to squeeze money out of everywhere that they possibly can. Have we ever walked into a store and seen where they just didn't have any EPRs? No.
Sure. You're at the case.
They're there.
I had to cut a couple
There, we have them somewhere, right? So all these customers would not be using them if they weren't required, right? It's not like optional. It doesn't make it run better, right? It's mandatory, okay? Mandatory. Or they would admit them and save thousands, right?
Yeah, no control.
So, and that's a problem that a refrigeration tech often has, is he looks at this thing going, I can just open it up, right? I'll just run it rack pressure, right? We can't. We cannot do that. It will not work properly, right? There's a couple problems that are gonna happen. One, I'm gonna start hitting my cut in, cut out to keep my evaporator from freezing the product, right? Well, that's gonna change my load on my rack. What's that gonna cost?
Short cycle, mechanical cycling.
It's gonna be what?
Mechanical cycling.
All right, so if I'm mechanically cycling my EPR, or my liquid and suction stops, turn that on and off, why is that bad?
Then we're gonna turn compressors on and off.
All right, I'm gonna change load, and that's gonna cause my compressors to stage. I'm gonna turn compressors on and off. Okay, why is that bad?
Energy usage.
Energy efficiency, out the window. What else?
Your suction pressure's gonna swing up and down.
Suction pressure, why is that bad?
Oil.
Yeah, bad for your oil return. Yeah, you'll lock out, or depending, if you get too low, you could lock out a compressor.
All right, I'm definitely gonna have oil problems. What else?
Case temps, product temps.
How about the life of that compressor?
You're shorting it.
Right, starting that compressor is the worst thing I can do to it, right? Yeah.
Just leave it off.
Yeah, so I'm destroying my compressors, I'm blowing my energy efficiency out the window, and I'm creating oil problems. That's, right? Now, we haven't even talked about my product. When my suction goes up, is my product cold? No, it's warming up, cooling down, warming up, cooling down. Right? What do you think my average core temp is gonna do?
Warm up.
It's going up. Right? So my product integrity that I'm now selling is also compromised. All that happens because I said, I'll just run this thing at rack pressure. Right? Yeah, no, so it's critical. So they're critical. My point is they're critical. They're also, like I said, what differentiates parallel rack refrigeration from single circuit refrigeration. Right? I can't have an EPR on a single circuit system. Right? But now I've got multiple compressors, multiple evaporators all tied together. I can't. This is why grocery stores, one of the many reasons, why grocery stores use parallel rack refrigeration instead of single circuits on everything. My point to all that is, it's critical that we set up our EPRs and we get them running properly, right? It's critical. For startup techs, you're never gonna pass BPR if your EPR is not on the button. So let's look at a few things here. This is my rack legend, right?
Yeah.
One of the things I'm gonna see on here, SST,
Yep.
right? SST, what is that?
Suction saturation temperature.
Suction saturation temp. Okay, what does that mean?
Average coil temperature.
All right, average coil temperature. That's the temperature that I'm supposed to dial in that coil to run. That's the temp. All right? How am I gonna calculate that? What is that in PSI? All right, it's giving me, let's say this one says 18 degrees.
You're gonna whip out your handy dandy Dan faucet.
What's that?
You're gonna whip out that handy dandy Dan faucet.
No, Honeywell PT is the.
Okay, so to convert this temperature into a meaningful pressure, because I've got an evaporator pressure regulator, when I set pressure, right? To convert that into a meaningful pressure, I've got to use the PT chart. So what else do I need to know?
What refrigerant you're using.
Refrigerant type. Yeah. So does midpoint apply here?
Yes.
Or are we going with dew point, or are we going with bubble? What are we doing?
You're gonna have to figure that out.
404?
Midpoint, you're at saturation.
Probably wouldn't matter.
We're at saturation, probably won't matter. We're at saturation, all right? Are we finding superheat?
No.
Are we finding our condensing temp?
Nope.
We're not finding subcooling, we're not finding superheat.
Just temperature.
We're finding the actual saturation.
Yep.
Is that dew point,
No.
bubble point?
Nope.
No.
Midpoint.
It's midpoint.
Technically it's both, but yes.
It is midpoint, okay? So our EPRs will always be set to midpoint, okay? So I need my refrigerant type, that's the other thing I need, that's on my sheet, all right? My refrigerant type is gonna dictate how critical that midpoint bit is,
Yeah.
right? R22 has no midpoint.
Yep.
It's easy, just got one temperature,
449? That's a lot.
right? 744 CO2, no glide.
No lies. Yep.
Right? No mid, no dew point, no bubble, no mid, it's all the same, right? That's awesome. 407,
11
449?
11 degrees, 12 degrees glide, right? Yeah, it really matters a lot. All right, this one's 404. How big of a difference is 404?
About 1.
Somebody run that, 18 degrees, 404, what's dew and what's bubble?
It's about 1
18
degree, but-
plus 18? Or minus 18?
On almost all 404. On just the spectrum, it's about 1 degree.
Yep.
18
That's
degrees?
what I expect.
Don't matter.
I haven't run this, but yeah, that's what I expect.
Usually
Dew
about 2
19,
PSI.
bubble 18, midpoint 18.5.
Say it again?
For E1 link.
Yeah, what's the dew? Pressure for 18 degrees at dew point on 404.
Oh, 18 degree pressure? Let me see.
18 degrees
18
is how many,
degrees, you're
how many PSI?
52.72 dew point,
Negative
53
17,
point.
negative 18, negative 17.
18 degrees is how many PSI?
52.72 dew
You want
point,
mid-
and
52.
53.98 bubble.
All right, 404, about a pound, right? And I need midpoint, that's half a pound. Okay, that's probably finer than I'm gonna be able to actually dial in this EPR.
Half a PSI.
All right, so 404, it's not a big deal, all right? 407 is, 448A, 449A, both have significant glide.
Yes.
Are all three, right? They do have significant glide. So I gotta be aware of that when I'm going to dial in this pressure, all right? So my SST is 27. That means I want that pressure 52.
53, oh, midpoint was 53, but dew
53.
point's, yeah, 53.
So I want 53 PSI on the outlet of my evaporator coil.
Yep.
That's what that means. SST is the evaporator,
Yep.
right? Now, most of the time, EPR is not in my evaporator. It's in the rack. So if I dial that in at 53 PSI in my rack, I may not be at 53 PSI at my
What's
evaporator.
your PSI?
I gotta account for that difference. We call that drop,
20 or none?
right? I gotta account for the difference in
Yes.
drop. Okay? If my EPR is at my case, I still could have a very small drop because I'm probably feeding multiple cases, so I still have some piping in the case. But I need to validate that and make, see what that is. If it's less than a half pound, something like that, go ahead and dial it in, all right? Now, second thing I'm gonna tell you is, this is in the lab. This is that lab setup, right? That's where they figured out that 53 degrees. That may not work for us. It may be close, but it's not necessarily perfect. So I'm never gonna dial in 53 PSI and walk away and call it good. I gotta let the case run, see where that 53 got me, and then make a fine adjustment from there. It is my starting point. Okay? It's not the ending point. It's the starting point. Does that make sense? Kind of like superheat,
Yep.
same game. Set it up 6 degrees and, I don't know, let's see how that works, right? I may have to tweak that a little bit, right? It's the same, okay? Because I'm not in a lab, that's why. So if I look at that, I just blew that SST segment up. Just check out this rack, right? I'm running minus 27 degrees here. All the way up to 18 degrees on the same rack.
Yep.
Those are vastly different pressures,
Yeah.
right? So this is why I'm running EPRs, okay? Because the case doesn't give a if I set the pressure to where it needs to be for this SST. It doesn't care what's downstream, right? As long as it's lower, okay? All right? And that's a pretty common example. That's going to be your bunkers that run as cold as they can run. And then, you know, I threw a seafood case on that rack because it had room. All right. So, different types of EPRs, okay? First one, we've talked about the A8. This is our third time talking about the old A8 valve.
It's almost like it's universally compatible.
Almost like it can do a lot, yeah. All right.
We hold back a lot of pressure.
Now, this particular version that I'm going to use for my EPR is specifically for an EPR. All right? My other valves, they didn't care if they were regulating liquid, they didn't care if they were regulating vapor, they didn't care if they were inlet or outlet, they could be either one, right? They didn't care if they were differential or if they were trying to maintain a specific pressure, right? You can get them in all those configurations, all right? This one, you cannot. You can only get it in one configuration. And that configuration is it's controlling the, well, here. Solenoid, Parker, open on rise of the inlet. It's the only version there is, okay, of a sport valve. And a sport valve is an EPR specific A8. Now, could I use an A8-1 that was also open on rise of inlet? I could. Yeah, I can, right? But this one is specifically designed to control that pressure very, very precisely. I'll have much more precise control with a sport than I will an A8, 1 or 2 that's doing the same job, right? The other thing that's different about this than our regular A8 is the pressure range that it can manage. Since it knows it's going to be an EPR, its pressure range is much smaller. 120 PSI is going to be max on my sport. Whereas my A8 can control 400, 500 pounds, right? All right. Another variance is on the sport, because it knows it's going to be an EPR, controlling vapor only, right? The orifice and the size and everything is much smaller, much finer in this, can't handle liquid. Right? My other A8s just don't care, right? This guy cares a lot. You give him a slug of liquid and you'll see your pressure go all over the place. Okay? So those are the big differences between the A8 versions that we've already talked about and this particular one. It's gonna say the word sport on it. All right? Solenoid means I can turn it on and off. That's optional. I could have a port valve that doesn't have a solenoid. Okay? Parker, they're all gonna be Parker. This comes from Flowcon, was what they originally called these valves years and years ago. They were gonna sell them as Flowcon. They were gonna change the brand. So they wanted to designate that Parker was involved. Well, as you guys know, Parker bought Sporland instead. And now they're just happy to say, hey, we're still in the game for Parker. Yeah, something like that. All right. And then our open on rise, okay? The piece they left out of this is inlet. Open on rise of the inlet. That means flow coming into the valve. That's my evaporator, right? So that's telling us, since it's open on rise of inlet, that means I'm controlling the inlet side. I don't care what happens on the outlet side. Don't care. As long as that pressure stays lower than what I'm trying to control, I'm going to hold that pressure. Right? That's what that means. Okay? The T, whatever. That means it has a Schrader.
A tap, yeah.
I think an S probably would have been a little better. Service port, I don't know, something, alright, so what that means is anytime I have a sport valve, I've got a place I can screw on my gauge, right? And in this case, it's gonna show me the evaporator pressure. It's gonna show me what I'm trying to control, right? We do have to watch that, cause that's not always, alright? But on a sport valve, it is. Okay, so anytime I'm adjusting my EPR and I can't find a damn service fitting on the evaporator side, it's on the valve. Okay, if I have sport, it is on the valve. How do I size this thing?
Correctly.
Correctly. Correctly is the magic word. Just like my other A8s that we talked about, I've got two different size measurements. I've got the orifice size and I've got my plumbing, right, the size of the copper. Right? I'm gonna spec this valve based on the orifice size.
Yep.
Alright, and then I'm just gonna match it to fit whatever's convenient for me to solder in, okay? Now, why am I going through all this? As service guys, this isn't something we have to deal with very often. Startup guys, yeah man, you gotta make sure you're putting in the right valve, okay?
Please put it on the
Alright, now, one of the things about this chart that you look at is that it's gonna give me pressure drop for each one of these tonnages. Alright, this is the size of my orifice, 03, 05, 07. If you guys remember from our A8 class, that's gonna be 1/8 of an inch. Right, that's what that is. Right, if I look at that for the same capacities, I can see that I can have different pressure drops. What pressure drop do I want?
Whatever your line size, or line length is.
Well, I mean, you don't want, yeah.
If I can choose, and this is telling me I can have 1 PSI drop, I can have 3 PSI drop, 5 or 10. What do I want?
Yeah,
As low as possible.
As low as possible.
Yeah.
This is my suction,
Trick question.
how many compressors I have to run to achieve to get the suction. The more compressors I run, the more power, right? I want to run my rack as high as possible, right? That means that pressure drop, I want it to be as small as possible. I want to use the lowest number, 1. That's what I want to use. I'm always going to calculate this on 1. It's going to give me the other value so I can see how screwed I am if that's the only valve I can buy,
Right.
right? But I can do that math. If I'm supposed to be running at rack pressure and I got a 10-pound drop there, I'm going to be running 12, 13 degrees warm, and it won't work.
Yeah, and
Right.
that tells you if you can buy that valve or not.
Yeah.
That tells you if you can, when you're
Correct.
sitting at the counter of the supply house, can I
Yep.
get away using this or not? Depends on how close the
Or
saturation of that
for-
coil is to the saturation of the rack.
Exactly.
For most of our startup guys at night, whether or not, you got what you need.
Yeah.
Correct.
Is it gonna make
That's
it in
right.
the morning or not?
When you start up and you show up and they give you your valve package, right? You need to be doing this research, checking this valve to see if it's the right one. Okay? Yeah.
Cause if it's close, stick it in.
Yep.
If it's not,
If it's going to work, stick
Is
it
it
in,
going to
not
work?
if it's close.
So,
If it's
so
going
what am I gonna evaluate? Is it gonna work? Well, when I look at my legend, can I even get away with it? Right? If I'm installing this on a minus 27 degree case on this rack, that's a minus 27 degree rack, if I've got more than a pound drop, it's not gonna work.
Yeah.
It will not work. My case will not make temp. Right? If I'm installing that same valve on this 18 degree case,
Yep.
on this same rack that's running minus 27, and I gotta open it an extra 5 pounds, will it work? Yes.
Oh, yeah.
Yeah.
It absolutely will work. So, and this is, now we're zooming in on it, right? Here's my port size right here.
Yep.
My connection size is actually smaller. Right?
Yeah.
So when we're looking at capacities here, the other thing to note, these are in tons. Okay, that's 1.44, that's 1.14, that's a ton, okay, that we're talking about. Now, if we remember, there were some correction factors when we were talking about TXVs. You suppose there are correction factors here?
Absolutely.
Yeah, there are. All right, so, and they work the exact same way. The correction factor we need to use is liquid of temperature, temperature of the liquid.
Yep.
Subcooling. Subcooling. Right, subcooling matters, because think about this, if I'm subcooling my liquid, I don't need as much of it to do the same job.
Right.
So therefore, I'm not gonna flow as much, right? Well, this is controlling flow. Does that matter? Yeah, there's a correction factor for your subcooling. All right? Just know that.
So, your EPR is controlling the flow versus your expansion valve is regulating it.
Correct. All right, this is fundamental and core that everyone understand this. All right? The only thing controlling superheat on my rack, the amount of refrigerant I am actually flowing, the amount of refrigerant I'm actually flowing are my expansion valves. Or EEVs, right? My expansion device. It's the only thing. Okay? This guy has nothing to do with superheat at all. Period. All right? My EPR cannot change my superheat. If I set up my gauge and my temperature probe and I'm calculating superheat and I change my EPR, will I see a change in superheat? Yeah, absolutely. For a few minutes until the temperature stabilizes and my copper catches up on temperature, and then it'll be the same. Before I leave the AA, I'm just going to remind you guys, once again, we've already talked about the AA 3 times, right? This is the 3rd time. So I don't want to cover it a lot. But just remember that I can change the cartridge and get a different size opening here. Okay? I don't have to replace the whole valve.
Really?
I did not know that. Okay. All right, that's true for all the AAs.
Okay.
All right, maybe I didn't cover that very well. So
You can change the.
there are some real advantages, some huge advantages of the AA valve. One is it's completely rebuildable. I don't have to take it out. Right? There's probably not much in the body that could go wrong. If I've got something wrong with the body, I'll see it when I take it apart, and I'll be able to get it out because there's going to be something stuck in it.
Plug.
Right? A plug. Right. That's where it's going to go. Yeah. If it's on the suction side, that's where it's going to get stuck. Right? Then I've got a cartridge inside that has the piston that moves up and down. Okay? Something can go wrong with that for sure. I can replace the cartridge. It's replaceable. I can also change the size of that connection orifice with the piston, with that cartridge. Change the cartridge, you can change the size.
Yep.
Which also means if I have a spare cartridge laying around, it may not be the right one. Right? For the valve that I'm working on. It's gotta have the same size opening, right? The same orifice size.
So as far as sizing it goes, is this, because it says R22 at the top, so that's only applicable for R22, or is
A
that?
little louder, I'm sorry.
So as far as sizing it goes, it says R22 on the top, is that?
Yeah,
Yeah.
so I just gave you one page, there's 20 pages.
Yeah.
Alright,
Absolutely.
but the point you're making is if you go looking for 449A, it's not gonna be in there, right? Because there's so many refrigerants. So now I've gotta find a refrigerant that's kinda similar,
R20.
that they do have listed,
Yeah.
right? For the new gases, because they're just not available. They're updating this list all the time. And by the way, I got this off the website for Parker. But this is in your library, okay? So every document I'm showing you in this entire presentation, 4 courses worth, they're all in the library,
Love that.
all right? That's where I got them. And there were a couple that weren't in there, and I had them.
The 50 mark over.
The other EPR we run into a lot is the Sorit valve, okay? This is way more common than the AA, right? There's a reason. There's a reason why this valve is much more common than the A8.
Small.
One of the advantages of the A8 is it doesn't require pilot pressure.
Yep.
That means I can put it in a case, right?
Yeah, but case.
The Sorit is pilot operated.
Yep.
That means it's pretty much gotta go in the rack. Alright, so why would I use one over the other? Okay. The A8, minimum pressure drop you just saw was a pound,
Yep.
right? I can have 0 on a Sorit. I can engineer it to 0.5. Less drop. We just talked about how critical that is. I want the lowest drop I can get. That means I am gonna run hot gas lines and pipe the crap out of my entire rack just to not have a half pound? Yes, that's what it means.
Increased efficiency over
Yep.
the life of the valve.
Yep.
Over the life of the rack.
That's how important it is that I not have drop. Okay? When you're sitting there in the middle of the night and you got a 3/4 inch coupling and you need a 7/8 and you're like, this little bit of suction drop won't matter. Think about that.
Joy.
Yeah, it will. Okay? So my Sorit, okay, my A8 was Parker. It's made by Parker. They're the same company now, but Flowcon Parker is Parker's version of an EPR. Sportland's version is the Sorit valve. All right? These valves used to compete directly with each other. Now they're the same company, and so they're marketing no pilot versus less drop, right? All right, but they weren't. When they were designed, they weren't. So my Sorit valve is solenoid, right? Same. I don't have a P in there for Parker. And I've got open rise of inlet. They use the I. They're both doing the same thing. Why aren't they the same letters? Because it's just Sportland came up with throwing the I in there, and Parker decided it wasn't important. I don't know why. So when we're talking about a Sorit, all right, or a Sport, they're both solenoid operated. They're both opening on rise of the inlet. They're doing the same job. Okay, exactly the same, just slightly different terminology because of the two different companies. That's all. Right? That's all it is. Just like Parker, Sportland thought it'd be great rather than saying Schrader or Service to give us the stupid T
Source.
for tap. Okay?
Source.
Just like the Sport, that in this application, that tap is on the side I'm controlling. It's on my evaporator side. So I can put my gauge right on it and dial in my pressure. Okay? All right, those two things are the same. All right? I've got 3 different sizes of this valve. Right? The 12 and the 15 look very similar. They're just physically, the 12 is smaller than the 15. 15 is a little larger. The 20 looks significantly different. It has bolts through the top instead of a screw fitting that holds it all together. All right? Those are the 3 versions of the Sorit that I have based on the size of the orifice. Now, unlike the Parker, where I can get very specific about the size of my orifice, I only have 3 on the Sorit. It's not as critical. Okay? It's nowhere near as critical. So I don't have to worry about being 1/8 of an inch off. Right? Okay, but here's the big change. Pilot operated. All right, it's pilot operated. This makes it far more complex. It's a far more complex valve, but it requires almost no pressure drop from inlet to outlet. All right, my A8 operates. Its only energy that it has is that difference. So that 1 pound that we were talking about, I gotta have it on an A8. I gotta have a pound drop. I don't want any more than that, but I gotta have 8 pound. All right? On a Sorit, I can go to 0. It just doesn't care. Because it's getting its energy from a pilot line, not the difference in those 2 pressures, inlet and outlet. All right?
So, an A requires 1 PSI.
It does. To regulate. Right. They'll just go wide open if it doesn't have it. Okay. So I can control very, very precisely with this valve with next to no pressure drop because I am supplying it with pilot pressure. All right. But that does make it more complex significantly. What does that mean? All right. Well, what that means on this drawing, I've got a bunch of different pressures going on. I've got my inlet pressure. This is my evaporator pressure. P1 is my evaporator, right? And that's going to flow up here to here. All right? I'm going to add P2. This is the spring that I turn. When I'm turning the end of this thing, I'm compressing that spring and increasing this force. All right? P1 and P2 are going to go together right there, and they're going to push against P5. That's my pilot pressure coming in the other side. All right? When they do that, they're going to control an itty-bitty tiny EPR. What? There's a little tiny EPR inside of this giant-ass EPR. Right? It's a needle. It's a needle and an orifice. Okay? The needle and the orifice, when it opens, just like a TXV, it's going to allow a little bit of refrigerant to come through. If it opens a lot, it'll allow a lot of refrigerant to come through. All right? that refrigerant that's coming through is my pilot pressure, and that pilot pressure is this P3. And it's gonna push down against P4, which is a spring in the bottom of this valve. All right? So what it's doing is, it's just regulating pilot pressure. It's very, very precisely through that little tiny hole, using the amount of pilot pressure to drive a giant mechanism.
Yep.
All right? Big spring, that's gonna be my big opening, okay? All right? So that's how the pilot works. So when I'm adjusting this valve, all I'm doing is moving this spring, and I'm controlling how much of that pilot pressure is pushing against that spring.
Yep.
All right? Now that I've said that, this is it, okay? This guy is complex, okay? We can see he's got a bunch of different flows. I left this off because it's got holes on every side. And I want you guys to be able to turn it around. I broke it. I want you guys to be able to turn this around and look at it
I'm just saying.
and see where these holes are. The other thing I did is I took different colors and added, green right here for that thread and green on that thread. So you can see how it assembles, okay? You can see where the pieces and parts go. This little tiny EPR I'm talking about is here, okay? Right. Don't want to drop it this time. All right, it's right here. Here's my seat, and the needle is inside here. All right, you can look at it and you'll see it down inside that. That plugs that little hole. That's what's controlling, that's this part right here. Okay, that's controlling my pilot pressure and reducing P3 so it's not pilot pressure P5. All right, that's what's doing that. It's this little space right here. Now, what can go wrong? Okay.
Yummy.
You think one or two things, right? Go
Yeah.
ahead.
You can get a piece in the system and it plugs up that tiny little hole, just like it
Or
plugs up your air.
Okay, I can plug that hole up,
Yep.
right? Well, if I look inside here, I'm gonna see there's an even smaller hole. Right, that's where that P3 is flowing into that chamber. It's a little tiny hole in the back.
Yep.
Plug that up,
Yeah.
right? Absolutely. Could I plug up any one of these holes and cause problems? Yeah.
Sure.
Right.
Yep.
Do I have a few of these holes? Yeah, I got a gazillion. Like I said, I'll pass around and let you look. The pins that fit in here, that push against this.
Yep.
All right, those are those pins right out of the TXV. Okay, a lot of these parts are going to look very similar to parts you've already seen in an expansion valve. The reason, because Sportland reuses what they can.
Right.
Right?
They already have them in stock. Why not use them?
Do what?
They already have those pins in stock. Why not use them?
It's efficient.
Right?
Yeah.
Can I take this valve apart and rebuild it on site?
Yes.
Yeah.
Yes,
You can build it and clean it on
You
site.
can.
absolutely can. Right? Without soldering, taking out my solder. Yeah, this unscrews. So I've got this glued in here, but this piece, without that locking ring, without that ring, it's the only piece that's missing, right? Lifts off.
Yep.
Okay? All right? Yeah, go ahead and pass it around. So I'm going to talk about two other really powerful tools that we get with this pilot operated idea. All right? One of them is I can close off this valve and use it as a solenoid. I can close my suction, all right? This valve, unlike my A8, this is a normally open valve. If I fail, this valve will be open, all right? So what that means is, in order to close it, what I've got to do is just bypass my mini EPR and cause my pilot pressure to go full bore straight down. That'll slam it closed. All right? So I'm going to do that with a solenoid. So when I energize my solenoid, I open a port that allows that pilot pressure to go around my little tiny EPR, and that creates my pressure. P3 becomes P5, and that drives that straight down and closes my valve. Okay? So I've got a suction stop built into this valve. Very cool. All right? That's a problem I have with an A8. It can't close. I have to have a solenoid. Okay? The other really cool thing that I have on this, and you're not gonna find this documented anywhere, I don't know why, that is, I can also use this valve for dual temp. and it doesn't require any other valve. Every other system that I use, I gotta use an A8 for medium temp and then have a bypass that opens the suction for low temp or something like that. Alright, so for my dual temp setup, the traditional setup is gonna use multiple valves. I'm gonna use some kind of EPR, and I'm gonna use a suction stop to close it and defrost, and I'm gonna have a bypass around it for low temp. Alright, this guy, all I've gotta do is put a solenoid in my pilot pressure. So if this pilot pressure, this P5 goes to 0, then P3 goes to 0, and since it's a normally open valve, it's gonna run wide open. I have no regulation. You guys got that? Right? So when I walk into a Walmart and I see a pilot line that has a solenoid in it, it's got a third solenoid. I got one for the suction on the EPR. I got a liquid line solenoid to close it off, and then there's a third solenoid in that pilot line. I know that's a dual temp case. That's all that I need for it to be a dual temp case. All right? As a service tech, I need to be aware that that phenomenon happens, because sometimes it happens when I don't mean it to. All right? If I've got a case that's cycling wildly, and I show up to set the EPR, and it doesn't adjust, maybe a pilot pressure problem. If I turn off my pilot pressure, it goes wide open. Well, if it's cycling wildly, it's wide open. If it doesn't adjust, probably don't have pilot pressure, right? Either I don't have any pilot pressure to the valve, or the pilot pressure is not making it to P3, and I've got a problem inside the valve. One of those two. So those are two really important features for the Sorit that no other EPR has, all right? All right, that it is its own suction stop, and it can be regulated or wide open with a solenoid, okay? Built into one valve, all right? Add to that almost no pressure drop across the valve itself, and you see why we're running hot gas lines all over my rack to make this work, all right? Port size, check that out. I only got 3. Remember I said we don't have to really split eighths of an inch and figure out 17 different ports? I got 3, that's it. All right, but that means I do have to size this guy, right? I do have to know which port is appropriate. When I look at that tonnage, you guess there's gonna be a correction factor for liquid temp?
Yes.
Yeah, there is. All right, the other thing to note here is on my adjustment range. I do have a few versions of that, okay? So what I want is the smallest range that fits the application I'm trying to run. Right? If I'm running low temp, I don't want a 75 150, right? 75 may work depending on my refrigerant type, but it's gonna be way down on the very extreme, right? I want this guy to be as close to the middle of that range as possible. Right? It will control all the way down to that very edge, but not quite as well. When I go into the middle of, same with TXVs, when I go into the middle of my adjustment range, my valve's gonna work the best, right? So I want to try to match, you know, what my actual suction is gonna run, okay? And then piping, okay? You can see the Sort 15, I got one version. That's it, right? So I do have less options here as far as piping and orifice, but it's because the valve controls so precisely that I don't need to size my everything just super close, right? All right, here's that capacity chart I was talking about. All right, this lists a couple different ones. Starts out with the ORIT valves, which we typically don't use. Other places do, right? The ORIT valves, which I'm not going to cover today, are super simple L devices with a spring.
Yep.
All right, you'll find those in the dual temp application with customers that don't use the Sort hot gas idea.
Yep.
That's typically where we find those. These are the Sort 12, 15, 20 are the 3 that we're talking about. You can see that my refrigerant type, I cut this off, it goes off to the right, and there's multiple pages, you know, same thing. This is my pressure drop. All right, the book will tell you, follow the 0.5, that's the one you want to use. They're gonna give you all the rest, so you can see what's gonna happen if you use something else. but you want to match the lowest drop you possibly can across this valve. So use the 0.5, use this to calculate your tonnage. Don't forget to multiply your factor for your subcooling when you're figuring the tonnage. The other application for my A8 and my Sorit valve, without the S, the ORIT, the other application where I'll find that is a loop. All right, if I'm running a loop and each of my loops have the same suction pressure, they have the same SST requirement, I only need one valve to control the entire trunk. Right, so I'll see that too. Right, walk into a rack and it has 3 circuits. Usually you're gonna see A8s in that application, but you could have an ORIT. Right? And when you adjust that little screw, you're adjusting 26 cases.
Every single one.
Right. Here's your correction factor. Guess what? If we look all the way out here, 90-degree liquid is 1, right? Is no correction. Right? Just like our TXV. Okay, no difference. Right? As we move through to where we actually tend to find our liquids, you're gonna see it's a minor, it's 0.22, right, or 0.17. But it does matter, okay? Especially if I'm on the edge choosing between 2. I'm blowing up the drawing here of the Sorit valve. That's what this is. If we look at it, there's a red line that comes off of this Sorit and goes to my discharge header. That's pilot line, right? Well, if I'm running hot gas defrost, that drawing is accurate. We haven't even talked about hot gas defrost. If I'm not, I gotta have some valve in here to regulate this pressure. All right? When we were looking at P5 was my pilot pressure coming in.
Not a solenoid.
You what? Question?
A solenoid doesn't regulate your pressure. You said something in line to regulate pressure, and they both said solenoid.
Nope, that'll close it. Turn it on and off,
Regulate.
but it won't maintain the pressure. All right, so hear me out. I'm explaining that. I'm explaining that. All right, on our drawing, P5 was our pilot pressure coming in. We were running P5 through that little tiny EPR and getting a very precise P3 pressure. That was pushing against my spring and opening the main valve. Well, if I change P5, won't I change P3?
Yes.
Yes, I will. So that means if my discharge pressure goes up or comes down, I'm gonna change the setting of my valve. Oh, that won't work.
Gotcha.
Yeah, because I got, weather and everything, and day and night. And, yeah, my discharge pressure is gonna move. All right? So the hot gas going to my Sorit valve has to be controlled very precisely,
Yes.
or my Sorit valve is going to hunt with it. Easy to miss this valve. It's hidden in the rack. It's hard to find, okay? Even easier to forget about it. When I go to adjust EPRs, if I have Sorits, the very first thing I do is dial in that pilot pressure, get it correct.
Yep.
Because if I change it, I change the setting of every Sorit valve, right? Not tremendously. It's not gonna be like 10 degrees and everything's gonna go bad. But it's gonna be 5 degrees if I change a lot, 6. What should we be setting it at?
90 PSI above the highest.
All right. So this is actually not clear cut, okay? And that's why I want to talk about it for a minute, all right? Your printed documentation, this is why you're finding them so low. Your printed documentation that says 50 PSI minimum over suction.
So they're checking suction pressure and setting it at.
So suction pressure plus 50 is minimum, all right? Okay, so if I read that and I think, and I don't know, and I think, then I'm gonna set that to 50 pounds over suction.
That's not right.
That's the absolute minimum possible for this valve to even work.
Yep.
That's not where I wanna set it.
No.
All right, I wanna set it significantly higher than that. All right, so a best practice as technicians is to go 90 over, 90 PSI over.
Over
Right.
highest suction.
Okay, now, here's part of my problems. This valve that I'm about to show you sometimes doesn't have that much range. Okay, and we'll talk about that in a minute. But I may have to compromise on that 90 PSI. That's why I wanted to talk about it. All right, depending on what valve I have. All right, So what valve do we know of that we can put in this pilot pressure
Or
that will control the outlet in hot gas in the range of, say, 100 psi's?
An
An
or valve.
Unfortunately, no.
Ha, nerd.
CRO.
Oh, CRO.
Okay, it's the same thing.
I've never heard of a crot valve.
All right, no one has. That's why I want to talk about it. All right. So he said or it. He said or it, right?
Yeah.
I got to tell you, when I was building this slide,
Wait,
I looked up an ORIT valve and pasted the picture in there, and I said, "Wait a minute, that's not an ORIT valve."
did Ian say or?
Yeah.
You told me to stop
I
saying
know
or.
it, I know,
You
it's the
just
same body.
It is the same body. All right. Once again, Sportland reusing the same material. I'm telling you, until I built this slide,
Yeah.
it was an ORIT. If you would have asked me, I would have told you it was
It's
an
a
ORIT.
crop.
Right.
It's an or, it's oriented backwards.
All right, here's the problem, right. ORIT is, ORIT open on rise of inlet.
Yeah.
We're controlling the outlet. But
And no, you're gonna
Sportland,
pipe it backwards.
doing what Sportland does, they had already developed the body of this valve for the ORIT, so they just used it. So it looks like an ORIT
Because
valve,
it is a Norit, but it works.
right?
But it's not.
Now, I know that's a crot valve, but you wouldn't know it by looking at it.
And the only thing that makes it a crot is the T. Usually it's just a CRO.
Yep,
And then there's a port on the discharge line downstream.
Yeah.
all right.
Yep.
So what the hell is a crot?
Silly goofy me.
Yeah.
Alright, this particular valve is close on rise of outlet. That sounds exactly what we want.
And bunkers.
The T is for tap.
Fuel tank.
Alright, that's my pressure. Now here's the rub, okay? I told you Sportland used the same body for the ORIT. The tap is on the wrong side. The tap is on the inlet because on the ORIT valve, that's where I needed it. Well, I'm controlling the outlet of this valve. The tap is on the inlet. This is one of those few times that you gotta be careful. If I screw my gauge onto that tap and then change my regulator, I will see no change.
Wait,
Nothing.
I'm sorry, I missed that. Screw the gauge on which one?
The tap is on the inlet of the pipe, so. if
Oh,
you-
you're saying
yeah,
it's going out.
Yeah, you hook up to the inlet, you turn that, then you're not gonna see anything, oh, you're gonna reach
We're gonna
discharge
read
pressure.
discharge pressure.
Yeah, you're gonna see discharge pressure,
That's what's
it.
gonna happen, alright? And that's only a side effect of them reusing the same body
Yep.
for the ORIT valve.
Yep, so
Okay.
take that tap on the line itself, downstream of the valve.
So what the hell is this thing? Alright? The other term that we will use, and far more often than crot, nobody calls this thing a crot. Just sounds almost obscene, right? I don't know why.
It does, it sounds.
It's like right on the edge of not
Dirty
okay.
word.
Crot.
Maybe that's when we were just in that one.
Alright, what everybody calls this thing is a crankcase pressure regulator.
Yep.
AKA.
Alright, and yeah, anybody who's messed with racks is like, what the hell are you
No, I
talking
know
about?
what a crankcase pressure regulator is, but I just thought that was your closing was.
Alright, that's what this is. If you look this up and you pull up any of Sportland stuff, it's all gonna be about controlling the pressure of a compressor
Yep.
to keep the pressure from climbing too high after a case comes out of defrost.
Yep.
We're just using it in.
Just to knock down the pressure so that I can't hit the compressor too hard
Yep.
with suction. Right, with suction pressure. Okay? Alright, we don't use it for that on a rack at all. That's a single circuit,
Yeah.
right? We don't use it for that. So for us, this is the only thing we use it for. So for us, it's a sort pilot pressure regulator.
I got
right?
this.
Either way, the terminology is CROT, C-R-O-T. Okay? Now, I just explained that everything you're gonna find about this guy is controlling a compressor's suction. And we just talked about, I'm controlling discharge, 90 PSI over suction. We may have a pressure problem. We may exceed the normal operating pressure of this valve.
Usually.
Yeah, we probably will. Okay. So
Like-
what are we gonna do about that?
Set it for
Nothing.
the max.
That is.
So set it to max.
So there's a couple things, keep that thought while we work through this valve. All right, super simple valve.
Yep.
It's about the simplest you can get. You got spring here, right? Pushing against my pressure here, and I just balance the two until I've got the same amount of spring pressure here as I want pressure on this side, and that's what I get.
Yep. Super.
Really simple, okay? Not super accurate, right? It will swing a couple pounds, right? Now, as far as an EPR goes, that'd be a huge freaking problem. Swinging a couple pounds is 2 or 3 degrees,
Right.
right? But, it doesn't really matter for pilot pressure. 2 or 3 PSI is good enough, right? That's why it's super simple. This guy's got a cap that screws on the top. It's threaded. It's one of the few places that you can use your channel locks and I won't lose my because it's round. It has no flat spots, right? That's what it's designed for. Inside here is an Allen. It just takes an Allen screw.
Yep.
Number 2.
Allen wrench, right? And you gotta just rotate it until you get your pressure that you want. Just remember not to use your pressure tap. It's completely useless. It is there for looks. It's there as a potential leak.
See, I replaced one.
All right? That's its only purpose.
Wee-wee.
My legend is gonna show me which version of this valve I have. I got one about the top there. They do come in different sizes. Now, here's one thing we need to know, is we don't have to size this valve. We're always gonna use a 6, right? That's a small one. Right, there is a 4, but 6 is the one we're gonna use. Why? Because we're not moving BTUs. We're not, we can't calculate tonnage of flow through this thing, because it's sort valves, they're barely using anything. Right? Barely passing any refrigerant through here. Alright, so 6 is the number we're always going to use. Then the second number that we've got is that 30-110.
30 PSI to 1.
That's my pressure range.
Yep.
Alright? Okay, so if I want to be 90 over suction, and 110 is the maximum that a standard valve can give me, this works really well on low temp.
Yep.
Not so good on medium temp. Alright, might have some problems there. Okay? So the standard valve, that's the standard valve. That's the standard CROT. I can walk in United and buy that valve, and it's gonna have 110 maximum operating pressure. Alright? The one next to it is an X55 CROT 6 with an 80 to 200 PSI temp pressure range. Okay, so the numbers just got weird. Alright? What that means is that X55 business is a special order valve. Alright? Basically, we asked Orland, hey, we like this CROT valve, but we need it in a completely different pressure range than you normally make. Can you do that? And they said, how many do you want? And Hill Phoenix said, 5 million over the next 20 years. And they said, sold!
Yep.
And off we went, okay? Now, what matters about this, couple things. I cannot walk into United and buy this valve unless they're stocking a special order CROT valve just for rack.
Whatever. Yeah.
Probably not,
I'll make
right?
You got lucky that.
They're gonna move one of these every 10 years, right? These things just don't fail either. Right, very rare.
Because they're very.
Okay, very low failure rate on a CROT valve.
I mean, you got
Okay?
a spring and a needle.
It's gonna start leaking refrigerant probably is what's gonna happen.
Yeah.
I've seen a few of them leak through the.
Yeah, through the cap, right. Alright,
New O-ring,
so but I wanted to just make you aware, right, that we do use 2 different ones, right? Not necessarily always the same, it also depends on the refrigerant type. But it's not uncommon at all to find that 110 on my low temp, okay? And it's not uncommon at all to find that 200 on my medium temp. If I have a problem with that medium temp, that 200, just know I can't go replace it easily, right? If I need that 110, I can walk in United anywhere, just tell them I want a CROT valve, right? Tell them I want a compressor regulator,
And we'll
pressure
see, we
regulator,
can order one for you.
crankcase pressure regulator.
Just question, if we do run into that valve has failed for some dumb reason, and it is a week out, at that point, are we taking that out of the pipe, just straight piping it in the meantime and watching our pressures and just doing the best we can to
Yeah.
get that rack running?
So,
Or-
yeah, so there's the question, right? Service tech has got a problem with the CROT,
Right.
and it's not letting any refrigerant through, or it's blowing refrigerant, it's leaking, whatever. Gotta do something there. Is it better to just turn off my pilot pressure and let my EPRs go to 100% wide open,
No,
or send straight hot pressure
Right.
that's gonna move around
Right.
That's what you want.
which is better?
the straight hot
Let it
pressure,
run
so
out-
you can't,
run it-
if you
run
do it
out.
that way, you're not gonna have any control of your medium temp.
These are the thoughts that we gotta have. You guys sitting here spitballing
Yeah,
this,
that's-
is all the right things to be saying.
Yeah.
Right, he just called out the dual temp problem. Well, if I got a dual temp case, it's gonna run low temp. If it's set to medium, it won't even run.
Right.
Yeah.
Right, that takes away that option, right? I gotta empty whole cases out. right? But yeah, those are the thoughts we need to have. My rack slamming on and off is gonna be miserable. I'm gonna have oil problems, I'm gonna tear it up, right? So no, I definitely wanna have less precise control and have my cases swing 2 or 3 degrees while I wait, then lock out 5 of my compressors on oil and destroy 2 of them.
So you're straight pipe.
So I'm gonna straight pipe.
Yep.
Yep.
Okay.
Does that make sense? But those are the debates you need to have.
Instead of straight piping it and doing all that work, could you essentially put a
A8 in there,
Well,
sure.
just
A9,
hose,
reverse
like,
that, you know,
just drop
outlet
a- drop a
operated
hose.
A9 valve would work,
you
yes.
drop a hose between the 2 forks, see if it works?
Sure, and it's gonna move a low enough volume of refrigerant that will work. Right, you guys hear what he said, you got 2 1/4-inch fittings,
Version of straight
put
pipe.
a 1/4-inch hose on that, I'd probably pull the Schrader cores out, so that I don't have that restriction.
Valve cores on.
So I've got a 1/4-inch tube,
Yeah.
what size piping do I have?
Usually 5/8, 3/4.
What's my pilot line?
Oh,
It's
Like a
like
super,
quarter inch.
like a super plus.
Hey.
yeah,
Probably gonna be just fine,
More permanent.
right?
be a quicker way.
Alright. So let's talk about that pipe.
Get it together.
Right, the last chunk of this I want to discuss is the pipe that feeds this stuff.
Yep.
Okay, what can go wrong here? My pilot pressure feeding this valve, what type of refrigerant does it need to be? What state?
Superheated discharge gas.
Superheated discharge gas.
Yep.
If I condense and send liquid to this,
Why
it
not?
will not work.
Bad.
Alright? So that is definitely a potential problem. I've gotta consider that. Alright? If I have a rack that does not have high enough discharge superheat, and I start condensing anywhere, I'm also gonna condense in this pipe. Alright, the reason I'm condensing is because I don't have any superheat, I'm at saturation.
Right.
And if I change the temperature to ambient, 1 degree, like at night when the temperature goes down, I'm gonna condense. That's gonna happen, right? Now, that shouldn't happen, that means I got something else wrong. Okay, we experienced that the other day, 1086, we were condensing inside the oil separator, right? That's one of the first places I'll see it,
Yeah.
is the oil separator. It gets cold, it starts getting condensation,
Yeah.
right? When I start seeing that, uh-oh. Well, one of my problems could be this pipe also. I'm not moving much refrigerant through here. If I walk up to that pipe and I touch it and it's hot, I got a problem. I got something internal, my little internal EPR is wide open. It's blowing hot gas right through it.
And you're talking about the equalizer line on, when you say when you walk up to that pipe and it's hot, you're talking about the equalizer.
I'm talking about the pilot pressure that feeds this,
Okay,
right? That big line,
okay.
half-inch line, big line comparatively, a little half-inch
Yeah.
line,
Hey,
right? That runs and has all my pilots coming off of it for every single sort, right? If I touch that pipe and it's hot, that means one of my sort valves is blowing hot gas into suction. Okay? My little tiny internal EPR is stuck wide open. Alright? That's what that means. Right? I should walk up to it and it should be ambient. Should be the same metals as the rack wall. Because I'm moving so little discharge through it that it's not actually heating up with the discharge gas. That's what I should have. If I walk up to it and touch it and it's colder than my rack wall, that means it has liquid refrigerant in it. And I've got liquid refrigerant going through a small metering device, going from high pressure to low pressure, it's gonna boil. Right? If I see that line sweating, that's telling me I'm condensing in that line. And I don't have control of any of my valves.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.